I would like to thank the organizers for giving me an opportunity to speak here on my research work. The title of the talk is Non-Equilibrium Tricritical Behavior in Anisotropic XY Ferromagnet. So this work has been done in collaboration with Olivia Mollik. She is a PhD student of Presidency University, Kolkata. Here is the brief list of previous studies on this non-equilibrium phase transition in XY and Heisenberg ferromagnet. None of these studies reported any kind of tricritical behavior in this system. And recently we have studied the non-equilibrium phase transition in three-dimensional classical anisotropic XY ferromagnet driven by elliptically polarized propagating magnetic field wave and observed the tricritical behavior. So this is the model of driven anisotropic XY ferromagnet. Here the first summation represents the spin-spin interaction with the anisotropy. This is bilinear exchange kind of anisotropy. And the second sum is the Zeeman term, basically spin-spin interaction term. And this H is the field of elliptically polarized propagating magnetic field wave. And we have also studied this for single site anisotropy. Here is the anisotropic interaction term. The elliptically polarized propagating magnetic field wave is given by this expression where this H0x and H0y are the amplitudes of the propagating field wave. If they are unequal, this represents the elliptical polarization, and if these are equal, this will represent the circular polarization of the propagating field wave, which is a special case of elliptic polarization. So this wave is propagating along this z direction and field lies in the xy plane. The lambda is the wavelength of the propagating wave and f is the frequency of the propagating wave. We have performed the Monte Carlo simulation and we have used the random updating scheme using the Metropolis single spin flip algorithm. Here is the probability of spin flip given by this Metropolis rate. We have calculated the following quantities, these components of the instantaneous magnetization and the time averaged magnetization components over the full cycle of the propagating field wave, this Qx and Qy. This will serve as the order parameter for this non-equilibrium phase transition. And we have also measured this dynamic energy density and the variance of the order parameter. And this gives you the Binder cumulant, fourth order Binder cumulant. So this is the result. Qx and Qy are plotted against the temperature. Qy is 0 for all temperatures. However, Qx shows a continuous phase transition. And note that here we have used the anisotropy strength for two different values of the field amplitudes H0x. H0y is always constant, which is 0.1. And we found that the continuous transition takes place for at higher temperature for lower values of the field amplitude. And we have measured the critical temperature, transition temperature from the position of the peak of this variance Qx plotted against temperature. And in the right panel, we have shown this dynamical phase transition, continuous transition for two different values of the anisotropy for fixed amplitude of the field. And here also we observe the continuous transition takes place at higher temperature for higher values of the anisotropy. So this critical temperature depends on both field amplitude and the anisotropy. Here also in some other parameter range, we observe the first order phase transition. Here this Qx drops suddenly, discontinuously at the transition temperature. The fourth order Binder cumulant shows a sharp minimum at the transition temperature and the energy density shows a sharp discontinuity at the transition temperature. The transition order of the transition has been confirmed by studying the distribution of the order parameter in different temperatures around the transition. Here we have shown the distribution of order parameter for second order phase transition or the continuous transition. At the ordered phase, lower temperature, we have a single peak at non-zero value of Qx, and as the temperature increases, this peak shifts towards the lower values of Qx, and not only that, the distribution gets broadened and it is an indication of the growth of critical fluctuation. And above the critical temperature, we have a single peak at around Qx equal to 0. So what will happen in the case of first order phase transition? In some other parameter values, we have the distribution of order parameter. In the higher temperature, the above the transition temperature, it is singly peaked around 0, and in the ordered phase, lower temperature, it is again singly peaked at a non-zero value of Qx, and very close to the transition, this shows a simultaneous two peaks, one around 0 and another at non-zero value of this Qx. And this difference, this separation of these peaks basically measures the amount of discontinuity in the order parameter at the transition temperature. And this gives us the comprehensive phase diagram. Basically, the critical temperature is plotted as function of the anisotropy and the amplitude of the field. This is the image plot, and this is basically a surface below which we have the ordered phase and above which we have the disordered phase. So this diagram is accompanied by another diagram. This diagram shows the order of the transition in different ranges of parameters. Here, in the red region, we have the second order or the continuous transition, and in the blue region, we have the first order transition. So that gives you the tricritical behavior in the case of anisotropic XY model driven by elliptically polarized propagating magnetic field wave. The same thing is observed here in the case of single site anisotropy. We have the continuous transition in a parameter range, and we have discontinuous transition in another parameter range. And we have also studied the distribution of order parameter here. In the case of second order transition, we have this kind of distributions, and in the case of first order transition, we have this kind of distribution. So though here also the close to the transition temperature, this peak is very not very prominent, but however here is a peak, probably we have not yet hit the right temperature, maybe it will be slightly higher, then we will have the first order transition. And here also we have the phase diagram like this, and this accompanying diagram which gives you the order of the transition. In the red region we have the second order phase transition, and blue region we have the first order phase transition, and there is another narrow region shown by the green region. So this shows the weak first order transition where the amount of discontinuity is very small. So the concluding remarks is anisotropic XY ferromagnet driven by elliptically polarized magnetic field wave shows the non-equilibrium tricritical behavior. Thank you for your attention.